Hello and welcome back. In this segment 8, we're going to look at problem solving with selection and repetition, and we'll spend more time in Eclipse in this video than with me talking at PowerPoint slides. So let's look at a spec and then go into Eclipse and write the solution in Java. So we're going to ask the user for an integer and then calculate and output all of the factors of that number. And here are a couple of test cases. So I hope you remember what factors are. Factors are things that divide evenly into a number. So these are the factors of 12 and these are the factors of 8. And let's just go do it. Let's ask the user for an integer, calculate and output the factors of that number, and let's go into Eclipse and do it. Okay, this is the example that I was using from the last video, and I'm going to use the same project, and I'm just going to dump a new class in here. So new class, and what will I call this one? How about factors? And I'm going to put a main method in here. So you can have more than one Java file with a main method in the same project. You just have to tell Eclipse which one of them you want to run or what entry point you want to use. And sometimes this is a little bit convenient because if you want to copy stuff out of your old one, I'm not sure that this is good advice. Maybe you should be memorizing these things. We're going to ask the user for something. So I'm going to make one of these scanner objects, and now we will enter an integer, and we can use print instead of print line if we want the cursor to stay on the same line, and then we want to store this in a variable. Number doesn't sound like a very good name, but that's okay. Okay, I think we're fairly confident that that works. We're going to ask the user for one number and store it here. Now, what we're asked to do is to output the factors of that number. So suppose the user entered 12. We need to make a loop, and we need to start someplace, stop someplace, and get there somehow. So I'm going to declare a control variable called factor, and let's say that factor will start at 1 and end at number. So there's no factors of number that are less than 1, and there are no factors of number that are bigger than number. So we have a start place and a stop place. Here's a for loop. There's the minimum. Make it a fill-in-the-blank problem. That's a little bit easier. So factor is going to start at 1. And factor has something to do with number when we stop. And we're going to go in steps of 1. I always do this when I'm making a condition. I put the two things that I want to relate to each other, and then I decide afterwards what relationship I want. So I want this loop to continue while factor is less than or equal to number. And why don't we see if this is working so far by just outputting all of the numbers between 1 and number. So let's run that. enter an integer, and we said we were going to try 12. And this program right now, instead of outputting the factors, it outputs all of the numbers that might possibly be a factor from 1 to 12. So the code that we have is working, but it isn't solving the problem yet. That's okay. This is called progressive testing. Don't try to do a whole lot and then test it. Do a little bit at a time and see if you got that part right, so that when you're fixing the mistakes, it won't take you as long to find them. So we want to test something. So we want to say if something is true, then output that number. So when is factor a factor of number? We can use the modulus operator for this. Let's try this. Number modulus factor is equal to 0. So if number is 12 and factor is 6, 12 modulus 6 is equal to 0. That's true. You take 2 6's out of 12 and have 0. And then we're going to output that that number is a factor. Let's try it. Enter an integer 12, and here are factors of 12. I suspect that when you're solving a problem like this, you don't just type it in and have it run. Set a breakpoint. Watch it run in the debugger. So we're going to click on the little bug. And I'm not sure what's going on now. Click on the little bug, enter an integer. It didn't switch the context. Okay, now it wants to switch the perspective. And now it's hit the breakpoint. Okay. Eclipse, it's a fairly complicated thing, and most of the time you just go along with it, and if it doesn't do exactly what you want, try it again. So when you're walking through code in the debugger, look at what happens. You have your local variables up here. We have a variable called number that has 12 in it, so that seems to make sense. And we don't have a variable called factor yet. Let's step over and watch this happen. I need a little more space up here. Now factor has 1, and we're going to execute this number modulus factor. 12 modulus 1 is equal to 0, and that's true, so we're going to go in and output the number 1, which is in factor, because 1 is a factor. Now what happens? Factor gets incremented to 2, then we test the condition. 2 is less than 12. That's true, so we're going in to test whether 12 modulus 2 is equal to 0. And when you hover over things in the debugger, you don't even have to look up here and see what's in the variables. It will just pop up and tell you. So we found out that 2 was a factor, and keep doing this. The Java program cannot hide anything from you. So you should never say, I wrote this program and I don't know why it's giving me this answer. You should say, this line of code is not doing what I want. And that's a much easier problem to solve. So Java executes one line of code at a time. It's a formal language. Everything does only one thing. We looped until factor became 12, and now factor became 13, so factor is less than or equal to 12 is false, and the for loop is over. Okay, I did something in this code that I don't like now. I declared my variable factor up here, but I only needed it inside of the for loop. So I'm going to change that. So this variable factor, which I only need in this loop, it can be declared right here in expression 1. And in Java, you generally declare your variables as close to where you need them as possible. In other languages, you declare them all at the top. And in Java, you declare them where you need them, and then they can go away faster, and it keeps your program from expanding too much and taking up too much RAM. So you use your variables when you need them, and you let them go away when you don't need them anymore. So let's think about this problem. We have a spec now that says ask the user for an integer and determine if the number is prime, and output a message indicating whether the number is prime or not. So 13 is a prime number, 15 is not a prime number. Remember that a prime number has factors only of 1 and itself. So it's not just that they're odd numbers, it's that they don't have any factors except 1 and itself. So it's related to the previous problem. We found all of the factors of the number, and we printed out the factors of the number. There's many ways to write an algorithm that finds out whether a number is prime. It's kind of a classic problem. If we wanted to change this one, that might be the fastest way. So what I'm going to do is just copy all of this code, and then I'm going to go over here and say new class prime throw away these comments. There's probably a way of setting Eclipse so that it doesn't put those in. So I just want what's in the main method. Let's copy what's in the main and paste it into our new program. So we have this program that outputs all of the factors. Darn it, I took the wrong one, didn't I? Okay, it's hard to type and talk at the same time. Now I have in this prime class the method that we had before, which prints out all of the factors of the number. And what we know about prime numbers is that they have only two factors, 1 and themselves. So there's different things that we could do. We could leave this code, this loop, the same as it is, and we could count how many factors we have, and if we have more than 2, then the number isn't prime. That's a good way of doing it, but I'm not going to do that way. I'm going to declare a Boolean variable. Call it isPrime. And I'm going to initialize it to true. Now I'm going to start at 2 because I know that 1 is a factor of everything. And I'm going to continue until we've gone to number minus 1. Or I could have just said less than the number. Maybe you'd like that one better. So we're not checking for 1 and the number itself as factors, and if we ever come to a factor in the range of 2 to number minus 1, then isPrime is going to be false. Now, after we've determined that the number is not prime or it is prime, then we're going to print out a message. So if isPrime, that's a strange looking if statement. An if statement requires something that evaluates to a Boolean. isPrime is a Boolean variable. It either has true in it if we didn't find any factors, or it has false in it if we did find a factor in that range. So if isPrime let's output the number is prime, else is not prime. Well, I don't have any red squigglies, so I think that there are no compiler errors, but I don't know if this is working correctly, so I'm going to run it. And it says enter an integer, and I'm going to type in 12, which I know is not prime, and it says it's not prime. A space would have helped here and here. Now let's run it and try a number that is prime. 13 is a prime number, and it seems to be working. In professional programming, this wouldn't be acceptable as a test. What we just did, we ran the code and we think now it's working. An acceptable test would be we set a breakpoint and we look at every line of code in the debugger and we verify to ourselves that every line of code is doing what we want it to do. So running it with a couple of tests and saying, yeah, it must work, that's probably not a good idea, because if you introduce a bug, and it will cost a whole lot more time than actually stepping through the code to see if there's a bug there. Okay, so that was fun. We got to exercise Boolean variables, and notice how I named this Boolean variable. Something that would make sense if you want to test it. So if is prime, that's very easy for me to understand what that if statement is testing for. You can almost read it in English. If is prime, do this, else do this. What you shouldn't do is name your Booleans in a negative way. I could have called this is not prime. Let's put a comment over here. Is not prime. Eventually, someone is going to have to write an if statement that looks like this. Okay, say that one out loud. If not is not prime. Holy cow. I can get my brain around if not is prime because I'm inverting something that's worded positively. But inverting something that's worded negatively, not is not prime, starts to, well, you get the idea. Don't do it that way. The convention is, if it's a Boolean, word it in a positive way so that you can tell what you're doing. And other people can tell what you're doing. Here's our third spec. And if you've been in a C class already, this might be familiar to you. I want us to write a spec that includes a sentinel controlled loop and a switch statement. So we're going to, in this one, present a menu to the user, allowing them to choose a dessert, include a price for each item on the menu, three choices. One of the options on the menu will be to exit the program. And after each selection, output the total price so far. And when the user chooses to exit the program, present the total price of their order. Okay, so I'm going to go and type some of the code to get this started, and then I will come back and show you what I've done so far. So this is what I have so far. I made a class called dessert. I hope that's not desert. I'm not really sure. And now I printed out the menu. So this is just some system.out lines that go to the user. You can pick these cakes, or you can say you're done ordering. This is outside of the loop. So this is a priming read for a while loop. And while the choice is not for, while they're not done ordering, then I do something with their choice, and then I ask them for the choice again. So this is the repeating read. It includes this elaborate prompt, and you get the next value and then see if they have quit. So what we're going to do in here with the valid data that they've entered, well, at least we know that it's not the done ordering option that they've entered. I'm going to put a switch statement, and we're going to switch on their choice. So if their choice is 1, I know that they have ordered coffee cake. And if their choice is 2, if their choice is 3, if their choice is 4, and maybe we'll put a default case if they did something wrong. I'm not sure why it didn't back that one up. Okay, so what do we want to do if they order coffee cake? We want to add the price of a coffee cake into some accumulator variable, and we don't have any of those yet. So let's make some variables. I'm going to make a final double coffee cake price, and it's going to be $2.99. And I made a mistake here. If it's a final, I want it to be in all uppercase using underscore for readability. And let's make a couple more of those finals. The cheesecake is going to be more expensive, and the carrot cake could be less expensive. And then we need a double that can change, so it's not a final, and it will be the total price initialized to 0. I really don't like it when people say initialize their doubles to 0, because you're initializing a double variable with an int. So even when it's 0.0, use a double if you're initializing a double, use a float if you're initializing a float, and so on. Okay, so if they order a coffee cake, they have chosen 1. In case 1, we're going to add to the total price the coffee cake price. And we're going to do something similar in case 2 and case 3, except we're going to use cheesecake and carrot cake. And there's a bug. We don't want all of these to happen. When we've done the case, we need to put a break statement here. If they enter something that is not a 1, 2, 3, or 4, let's just put a message back to them that says that's not on the menu. Be polite. And what do we want to do when they enter a 4? Well, nothing. We just want to get out of here. I know that you're tempted to put a bunch of code in here that says, now I'm going to give you the total price and all of this summary business, but you don't need to do that inside the loop. When the loop is over, now we can say whatever we need to sum up the end of the program. A couple of compile errors here. Does it work? You're supposed to say, I don't know, Dr. A. Let's run it in the debugger and see what it does. Well, I'm going to run it without the debugger first and see what happens. So choose from this menu. All those colons in there look kind of silly. I'm going to have a coffee cake, and then I'm going to say I'm done ordering. And a coffee cake is $2.99, so that seems to have worked. In the simplest case, this time I'm going to have a coffee cake, then a cheesecake, then a carrot cake, and then done. $8.97. That looks about right. Okay, so what did we do in this example? We declared some finals. These are things that we don't want to change throughout the code, so we have this little protector that those are constants throughout this program. We did a priming read that included a whole menu of prompts, and then a sentinel controlled loop. The repeating read includes the same prompt and input as the priming read, and then inside we processed what the user had entered. So this is a very common pattern for sentinel controlled loops. Very good. Let's go and look at another one. Well, I left something out of the spec when or out of the solution when I solved that. I put in the spec that after each selection you must output the total price so far. And I forgot to do that, and in fact I had made this test case here of things that you could choose, and I output the total so far. And then when I wrote the code to show you that, I didn't do it. So go back to the spec. Leaving mistakes in these videos is where a lot of learning happens. Go back to the spec when you're done writing the code and see if you actually did what you set out to do. If there's more than just a few things, then you probably forgot something, like I did in that example. Not a big deal. You can go and add those things back in now that we know we forgot them. Let's look at another one. So we're going to generate random numbers in Java, and there's a lot of reasons to generate random numbers, but you can write some fun behavior games and so on that allow me to make some more interesting assignments for you, quite frankly. So we're going to include or import rather the Java util random class and make an instance of the random number class and generate numbers and see if it's working. Generating random numbers in Java is really pretty easy. You just have to know how to do it. We're going to import Java util random, and I've been sneaking this in without really explaining what it does, and I think that's okay for now, so long as I can show you one that works and does exactly what I need it to do. There is a class called random whose job is to generate random things, and if you call your class, the class that you're making, if you call your class random, then you will have kind of replaced the Java class random, and then you'll run into all sorts of mysterious problems. Why doesn't it work? And that's kind of a beginner's error. Don't name your classes the same things that are already existing in the JDK, or they'll find your class first and try and use it. But Okay, so I made a for loop that will go from 0 to 9, or just loop 10 times. And this generator object that I made, you can call yours whatever you want, is going to generate numbers from 0 through 9. Okay, if you hover over these, you'll get some help. So pseudo-randomly, uniformly distributed between 0 inclusive and the specified value exclusive. So I wanted to just run this and see if we do get some numbers from 0 to 9. Okay, when you have an object like generator and you type the dot, you get help with what it can do. So an object of type random has all of these options. It could generate a random double, a random float by these next float, next double, a random int using this method without passing any parameter will generate all possible 2 to the 32 int values. So that will generate huge numbers. And then if you do specify a parameter, like we did, specify an integer, it will be from 0 to n minus 1. So IntelliSense in Eclipse will help you, and the Java docs will pop up so that you can use these things. So if I wanted to generate a number between 1 and 6, that was in the spec, I'm going to say next int 6 and add 1 to it. So next int 6 would generate a number from 0 to 5, and if I add 1 to that, then I would have a number between 1 and 6, which could be representing throwing a die, which is 1 dice. And that was part of the spec. And let's not make the mistake I did before. I'm going to pop back over to the spec and see what was I supposed to do. Roll a die 1,000 times and count how many times you got each number 1 through 6. Well, I think that that's pretty easy. It would be nice if we knew about arrays at this point, but we don't. So I'm going to declare 6 variables. If you roll a 1, I'm going to add 1 to that. And if we roll a 2, I'm going to add 1 to that. If we roll a 3, I'm going to add 1 to that. And so on. 6 of them. We need a loop that will go 1,000 times. Well, there's a counter control loop right there that goes 10 times. So make that go 1,000 times. We generate a number. From 1 to 6. And then check to see if we rolled a 1 or a 2 or a 3. We could use a switch statement here. We could switch on die, or we could use some if statements. If die is equal to 1, increment die 1, else if die is equal to 2, increment die 2, And I'm not happy with this because I would like to be using an array, but we don't know about arrays yet, so this is okay, even if it feels a little bit uncomfortable to you. And I've only counted if you roll 1, 2, or 3. I've ignored 4, 5, and 6 because I wanted this all to fit on one screen. So this is the first time that I've demonstrated something that's called an else if. There is no such thing as else if. There is no keyword else if. So this is an else that corresponds to this if, and that else has only one thing in it. It has an if statement. This else corresponds to this if, and that else has only one thing in it. It's an if statement. So this is one of the acceptable forms of piling up if statements with each one having an else clause, and you can see why we're doing it. If you have this case, then you don't have this case, and using the word case indicates that maybe a switch statement also could have been used here. And it's about 6 or 2 3s, as we used to say. It doesn't really matter in this case which of those you use. So an else if statement, and they stack up instead of indenting all the way across the screen. And a 1 occurs die 1 times, and a 2 occurs die 2 times, and a 3 occurs die 3 times, and I didn't do 4, 5, and 6. Those squigglies are really helpful to me because finding syntax errors sooner than later is a good idea. I'm just going to run this and see what it does. In 1,000 times, it generated a 1 157 times, and a 2 175 times, and a 3 171 times. Let's make it 100,000 times. It's pretty fast, isn't it? 100,000 times. These numbers are really fairly close to each other. Each time a slightly different count. So this would allow us to now write some games that use random number generators that correspond to rolling dice and so on. And it makes your programs a little more fun if they're non-deterministic. That means that each time you run them, they might do something different. And that's the opposite of deterministic code, which each time it runs, it must do exactly the same thing. Without any outside influence, formal logic does the same thing every time. So the outside influence here is a random number generator. Okay, so this one is kind of fun, but we learn stuff. And let's go back and well, we almost met the spec that time. We didn't do all 6 of them. So in summary, for solving problems that start to get more complicated, have a test case that demonstrates what you expect the result to be. If you don't know what the result should be, how will you know if your code is working? Develop progressively. So write a little bit of code, compile frequently. That will isolate compiler errors, and you can also use the debugger along the way to find your logic errors. so it can't hide anything from you. Use for loops for counter control loops. That's when you know how many times the loop is going to go. Use the shortcut operators wherever possible, so the incrementers and the plus gets, the compound assignment operators. Incrementer, decrementer, compound assignment operators. Choose your variable names carefully. There's lots of evidence that correctly chosen variable names will make your work easier. And I know that it's kind of boring to sit there and think about, well, what should I call this that would make it easier? And that's where you actually save time later on, if people, including yourself, can understand what you've done. Okay, very good. We're in a good place now. We can start doing some assignments that are more fun. I'll see you in the next video.